So we're going to do a quick lesson on converting area and volume. We're going to start just by looking at area measurements. So recall that the area of a rectangle is found by multiplying the length and the width of the rectangle. Also, both of the measurements have units. For example, inches. So when you multiply the length by the width, you are also multiplying inches by inches. And this is why area is often expressed in square units, or in this case, square inches, and is often abbreviated inches squared. Because of this process, we can convert units of area by using dimensional analysis. We must take this squaring effect into account. One way is to use two copies of the linear unit fraction. An example, we're going to find the area, we know that the area of a football field is 6,400 square yards. So we're curious as to how many square feet that is. So of course, just like usual, we'll start by setting it up. There is yards times yards, which is just the expanded version of square yards. And we're going to multiply it by feet, 3 feet over 1 yard. But notice that only cancels out one of those yards. So we actually need a second unit fraction in order to cancel out the second set of yards. And now we do our multiplication. And so we see that the numerator is 6,400 times 3 feet times 3 feet. Our denominator is 1, so we have 57,600 feet times feet, or square feet, over 1. So the football field would actually have an area of 57,600 square feet. Now, let's look a little closer at that calculation that we've made there. Notice that you have two copies of 3 feet by 3 feet over 1 yard times 1 yard. So we could actually compact this a bit just by writing that as 3 feet over 1 yard squared, because we've got two copies of it. And this would allow for canceling out both of the yards units. Or using the exponent rule, we could distribute that square and just write a single unit fraction of 9 square feet equals 1 square yard. And the units would also cancel out. Notice that both the number in the numerator and in the denominator have to be squared. And this might be difficult to remember if you're going to use these shortcuts. So we could just set it up this way. The square yards would both cancel out right away, and we'd still get 57,600 square feet. The squaring effect also requires a slight change to our process if we're converting for the metric system. Remember, we convert within the metric system by moving the decimal, which has the effect of multiplying or dividing by 10. But converting 1 centimeter squared to millimeters squared, we'll remember that a 1 centimeter square is actually a square that is 1 centimeter on each side. And we know that 1 centimeter equals 10 millimeters. So this gives 1 centimeter times 1 centimeter, which would be the same thing as 10 millimeters times 10 millimeters, which 10 times 10 is 100, and millimeters times millimeters is a millimeter square, or a square millimeter. So even though centimeters and millimeters are only one step apart in our little King Henry doesn't usually drink chocolate milk memory device, it takes 2 decimal moves to convert between square centimeters and millimeters, 1 for each of the tens. So we can convert using our same decimal moving technique. We just have to remember to multiply the number of moves by 2. Here's an example. The area of a soccer pitch is 7,140 square meters. What is this? What is this in square kilometers? Kilometers squared. Well, remember again, King Henry doesn't usually drink chocolate milk. And since, again, we're dealing with area units, we just need to double. So here's our little memory device. We're going to do 3 jumps. And so since it takes 3 jumps to get from meters to kilometers, we multiply that by 2 and we move the decimal 6 times. So here are our digits, 7,140. And remember, the decimal is actually right back there at the end of the 0. So we move it 1, 2, 3, 4, 5, 6 places. And so the area of a soccer pitch is actually 0.00714 square kilometers. Volume works very similarly because you're still just multiplying lengths. It's actually now, for example, inches times inches times inches, or cubic inches. So we would just have to use 3 copies of the unit fraction, or use the exponent 3 to convert volume using dimensional analysis. So suppose the volume of a swimming pool is 1,512 cubic feet. What is its volume in cubic yards? When we set up our initial calculation and you see that we have our cubic feet, we've expanded it out to be feet times feet times feet. So since there are 3 units of feet, we're going to have 3 unit fractions to convert each of those. So because we've got 3 copies, we can cancel out all 3 feet, but that also means we're going to have yards times yards times yards, but that's how we get the cubic yards that we wanted. And remember that when you have a number in the denominator of the resulting fraction, you divide that into the numerator product that you got. And in this case, it gives us exactly 56 cubic yards as the volume of that swimming pool. And again, converting within the metric system gives us pretty much the same result. We just have to remember that now we're going to make 3 jumps instead of 2 for each move through our little mnemonic memory device. Another advantage of the metric system is that the standard capacity units, or for example, liters or milliliters or kiloliters, are powers of 10 multiples of cubic units. So for example, 1 milliliter is actually the same as 1 cubic centimeter. And 1 liter is just 1,000 cubic centimeters. And a cubic meter is really the same as 1 kiloliter. And so we could make it's much easier to convert between the cubic measurements and the typical volume measurements in the metric system as it is to convert in all the other ways in the metric system. Now, if you need to convert between US customary units of capacity and cubic units, then you have to use approximate unit fractions because there aren't exact measurements for those. So for example, we'll go back and look at that pool again that was 1,512 cubic feet. What would be its capacity in gallons? Well, one of the things we have to know is that a cubic foot is more or less 7.48 gallons. And so we can set up a unit fraction of 7.48 gallons over 1 cubic foot. And we can actually make this conversion in a single step because we notice that we have cubic feet as part of this conversion, not just feet. So they do cancel out right away. We just make our multiplying effect here. And in the end, we get that the pool has a capacity of 11,310 gallons, approximately 11,310 gallons. So I hope that helps you to make the conversions, and now you should be ready to do your MyLabs Section 9.2 unit.